Working out problem number 3 from the Hardy-Weinberg principle, and the question basically states that a population of butterflies has the color brown, which is dominant and is represented by big B, and also has the color white, which is recessive, which is represented by little b. Now we have 40% of the population is white, therefore they're little b, and then that means that this is Q2 in the equation. P2 plus 2QP plus Q2 is equal to 1. This is one of the formulas we're going to be using. So for A, we have to calculate the percent of butterflies that are heterozygous. Now, when we're dealing with heterozygous, we're going to be using this portion of the equation. So what we're going to be doing is we're going to be multiplying 2 times Q, so we have to square Q, and times P, so we have to find P as well, P and Q. So now, what we're going to be doing is we're going to be doing 0.40, because this is a decimal format of 40%, and we're going to square it in order to get Q. Now, 40 squared, 0.40 squared is equal to Q 0.63, right? So now we have our Q. Our Q is 63. Now, to get P, we're going to be using this formula. Plus Q is equal to 1. So what we're going to be doing is we're going to be rearranging this algebraically, and we're going to get P is equal to 1 minus Q. So to find P, we're going to do P is equal to 1 minus 0.63. And P is going to end up equaling, P is equals 0.37. So now we plug in 0.37, and when we multiply that out, we're going to be getting that 0.47 of the population is going to be heterozygous. Now, to convert this into a percentage, what we do is we just simply multiply times 10, or excuse me, this is a 7. We multiply it times 100, or we simply move the decimal places. So the answer to A would be 47% of the population is heterozygous. Next we have B, and it's going to be asking for the frequency of homozygous dominant individuals. And this is basically P squared, because P squared is going to equal the frequency of BB, big B, which is brown. So then what we're going to do is we're going to get P, which is 0.37, and we're simply going to square it, or we're going to take it to the second power. So then P squared is going to equal to 0.14, and that is the frequency of homozygous dominant individuals in this population.